Hello everyone, myself Sowmya, Assistant Professor in CSE AIML Department, MLR Institute of Technology. In this video, we are going to discuss about limitations and challenges in blockchain. So we know blockchain is efficient, it is secured, but still it also has some limitations and challenges. We will see what are they. So coming to the overview of this presentation covers the implementation limitations. So like scalability, privacy, lack of technical knowledge, security concerns and flaws. And implementation challenges. So these are the limitations, and coming to the challenges. Transaction processing speed, complexity, implementation and operation cost, storage constraints, lack of governance and standards, lack of formal contract verification, energy and resource consumption, simplified mining, and human errors. So these are the things we are going to cover in this video. So coming to the implementation limitations. So what are the limitations we have in blockchain? So blockchain, of course, it is offering many advantages like security or efficient, but at the same time, it also has some limitations. So these are some limitations: scalability, privacy, lack of technical knowledge, security concerns and flaws. So first one is limited scalability. So if you want to design blockchain for complex organization or complex features, then it cannot provide the space. We know the POW, proof of work, the consensus mechanism, which needs more power, more energy. At the same time, in blockchain, the nodes are connected and all the nodes will maintain a copy of the ledger. So if it is complex, if you are having more number of nodes, obviously it has to provide more memory to save all these ledgers, right? So if the number of nodes are more, of the scalability is more, then it cannot give a good performance. So one is transaction speed. The transaction speed will be reduced. If more number is there, obviously the transaction speed will be reduced. So traditional blockchains like Bitcoin and Ethereum suffer from limited transaction throughput. For example, Bitcoin can process around 7 transactions per second and Ethereum 30 transactions per second. So why? Because if it is scalable, if it is more complex, then obviously the transaction will take more time. So next is network congestion. So if more number of nodes are there, obviously the congestion will occur. Block size and consensus mechanisms. So if you have more number of nodes, obviously the block size will be more. A block will contain more number of transactions. And consensus mechanism. While taking the consensus also, it will take more time. Next is limited privacy. So transparency of transactions. We know blockchain is transparent. Everyone can see the transactions, whatever you are doing, this will be visible to everyone. So even we can see, if we know any public key, anyone's public key, using that public key, we can check the transactions of that person, of that particular wallet. So what he is doing, from where he is getting the funds to where he is transferring the funds, everything with the addresses, with the amounts we can get. So that is transparent feature of this blockchain. So in public blockchains, all the transactions are visible to anyone on the network. While this ensures transparency and immutability, it can also a limitation in situations where privacy is a concern. And next is linkability. Even though users are pseudo-anonymous, transaction patterns can still be analyzed and linked back to an individual or entity, leading to a privacy concerns. So if we know any public key, yes, I can get the history of that wallet, to whom he is sending or from where he is getting, everything I can get. But at the same time, we know pseudo anonymous in the sense, this public key belongs to which person, that I can't get. But if I know the system's IP, I can get the person's identity. I can trace the person's identity using that IP. So that will lead to the privacy issue. So solutions for privacy. Technologies like zero knowledge proofs and confidential transactions are being developed to improve the privacy of the blockchain. So there's a solution. So to overcome these problems, they have proposed some solutions like zero knowledge proof. So zero knowledge proof is nothing but like, I need to convey some information. The person A needs to convey some information to B, but not directly. He shouldn't reveal the secret, but he should convey that information, right? So he should prove himself that information is correct, that information is valid, but he shouldn't give the complete information, only something like abstraction, right? So it's not showing the internal features on how exactly it works. For example, whenever you learn a car, so the person will teach you how to drive a car, but he doesn't teach you how hardware will work, how internal parts of the car will work, right? So something like that. Here also A will convey the information to B by providing some proofs, but he will not reveal the secret, right? So that is nothing but zero knowledge proof. So using this technology, something like we can overcome this privacy issues. So lack of technical knowledge. So one is complexity. We know blockchain technology is a new technology and we don't have a technical persons. I mean, we do have, but we have only limited persons who knows this blockchain technology, right? So it is can be difficult for non-technical users to understand, and even developers may struggle with implementation or maintaining the blockchain systems. So developer skill gap. So as we don't know this technology, it is a new technology. So that's why the developer skills, they need to improve. And adoption barriers. For businesses, integrating blockchain solution often requires a steep learning curve, as well as the need for specialized training for the staff and developers to handle blockchain platforms effectively. For example, I want to incorporate blockchain mechanism in existing bank system. So in existing banking system, we have some methodology, we have some developers, we have some training staff. Everybody, they are okay with the existing methodology. They are trained with the existing methodology. But if I want to incorporate a new thing into the existing methodology, then they have to learn that, right? So they have to adapt that. So that barriers will occur. Next is security concerns and flaws. So smart contract vulnerabilities. So as we know, a smart contract, once it is deployed onto the blockchain, we cannot modify that. So while blockchain networks are generally secure due to the cryptographic decentralized nature, smart contracts can have vulnerabilities. Bugs or flaws in the code could be exploited by the attackers, leading to a loss of funds and manipulations of the data. So this was happened in 2017, which was called as DAO attack. So a small bug in the smart contract, so which lead to a transfer of some $3 million of ethers. So transferred to some unknown account. So because of a small glitch, a small bug in the smart contract. So why? Because they didn't properly verify the smart contract before deploying onto the blockchain. So if it is properly verified, okay, no issues. But if it is not properly verified before deploying, once if it is deployed, you can't modify, right? So once it is deployed, we can't modify that. Because of that bug, the DAO attack was happened. So some amount of ethers transferred from one account to some unknown account. So next is 51% account. So sorry, 51% attack. So in POW, proof of work based blockchain, if a single entity or group of controls more than 50% of the network mining power, they can potentially manipulate the system. So in POW, it is something like the decision will be taken by something like voting. So if the 51% of the people says the transaction is valid, then I should consider that as a valid transaction, even though it is not valid. Why? Because the majority people are telling that it is valid. So if the 51% people are attackers only, so they want to attack, and the majority people are attackers only, and they are saying that this transaction is valid. So obviously I need to deploy the transaction onto the blockchain with some bugs, right? So with this, the attacker will gain, but the complete blockchain will be collapsed. So that is called 51% attack. And next is Sybil attack. So in the Sybil attack, a person will get the fake identity. So I have some identity X, then the person Y will come, but he will use the X identity and he will he will do the transactions. So what I will think, this transaction I am getting, the Z person is getting. So who is sending? Y is sending, but how he is sending? As X. So what Z will think? Okay, I am getting the transactions from X, who is trusted. Then I can, approve this transaction. Something like that he will feel. But actually he is getting the transactions from Y. So this is nothing but the Sybil attack. And private key management. So we know this blockchain is based on the cryptography where we are using public key and private key. But if we forget our private key, then entire thing will be lost. So recently I have studied one article where he bought some some number of blockchain, bitcoins in 2010. We know in 2008 the Bitcoin was developed. So in 2010 the Bitcoin price was less only, but now it is millions of dollars, right? So he brought some 1,000 Bitcoins around something. So he stored his private key in some hard disk and he lost that hard disk. So now he wants to get that hard disk back, but he couldn't, right? So because of that, he lost his private key. Because of that, now he's not able to sell that bitcoins. So that's the problem with the private key management. If we lost our private key, we can't. Then blockchain forks. So we can create the forks for blockchain using the existing blockchain network. We can create some forks or childs, something like that. We can create, but whenever you create some glitches or some problems, we may get in the next version, the newer version. So coming to the implementation challenge. So blockchain technology, while promising significant benefits in terms of decentralization, security, transparency, does face several implementation challenges. So we have some implementation challenges. While implementing, what are the challenges we are facing? So one is transaction processing speed, complexity, implementation and operation cost, storage constraints, lack of governance and standards, lack of formal contract verification, energy and resource consumption, simplified mining, human errors. The first one is transaction processing speed. So one is scalability issue, already we have discussed, right? So the Bitcoin is taking 7 transactions per second, whereas Ethereum is taking 30 per second. So this is the problem we are getting with the blockchain. And latency. So as a blockchain grow in size, it can take longer for transactions to be confirmed, especially in public blockchain where the consensus mechanism like proof of work can be slow and require significant computational power. So this is again the scalability issue. If the number of nodes are more, then obviously it will take more time to take the decision. And complexity, understanding the technology, as it is a new technology, it is very complex to understand. Integration with the existing system. So already you are using some existing system. If you want to integrate with the existing system, some expertise should be there to integrate. And smart contract development. So writing and deploying smart contract requires specialized knowledge. Again, it's a new programming language which we don't know. We need to adapt that to design a smart contract. Implementation and operational cost. So initial setup cost. Of course, blockchain is, as we discussed, if you are using bank, so for some amount RTGS, or if I want to transfer more than 2 lakhs or more than 10 lakhs, it will charge something, right? But blockchain, you don't need to pay. A small amount of pay will be paid, right? Extra fee. And you don't need an intermediary person here to maintain all these, right? So directly we can take the decision. So all these advantages are there, but initial setup will be more cost when we compare with the traditional system. And ongoing maintenance. Of course, the ongoing maintenance, whenever you need updates or whenever you need to update your blockchain, again, the maintenance charge will be occurred. And network fees. So public blockchain offer incur transaction fees. Why? Because they need to pay for the miners, right? So miners are nothing but who is going to validate your transaction. So they are validating. Of course, I should give some amount for them. So that amount will be in the form of tokens or coins. So storage constraints. So ledger growth. So if the ledger growth is more and this ledger will be maintained by all the nodes, then the storage problem will occur. That will lead to the data storage issue. And lack of governance and standards. So lack of regulation. Blockchain networks, particularly in decentralized environments, often lack clear governance model. While blockchain decentralized nature is an advantage, it can also lead to confusion over decision-making process, particularly in terms of protocol changes, dispute resolution, and policy enforcement. So as already we are using centralized thing. So if you want to take some decision, I'm taking the permission from some person, centralized person. That is fine. That is going well. But if I want to change this regulations, governance rules, everything needs to be changed. And we can't even trust all the time the blockchain, right? Why? Because there is no central person to take the decision here. The decision making process is very confusing here. If I take the 51% attack, the decision according to the rules, it is correct. But the 51% persons, the majority of the persons are attackers. then it may lead to some problem. So that's why even the government cannot trust this directly. I mean, if we prove this is really secured with all the proofs, then only the blockchain can be agreed. And interoperability. Different blockchain networks often operate on silos without standardized protocols to allow them to communicate with each other seamlessly. So if I want to get some information from other website or other resource, then I'm using this. But there is no trust, right? So whether I can trust that website, whether I can trust that resource or not, that it is not verifying. So that is again a problem. So lack of formal contract verification. So whatever the smart contract you are writing, so before deploying that, we should verify it properly. If we don't verify that properly, then like the DAO attack in 2017, that will happen. So a smart contract bug is nothing but it may be integer overflow or it may be anything. So the contract should be bug free before deploying onto the blockchain. So formal verification. Formal verification is nothing but it is an area where blockchain technology is still okay. The process can Formal verification is nothing but checking the smart contract before deploying onto the blockchain properly. Whether it is bug free or not. Bug free is nothing but like it's not like syntax errors. So we can, I mean, in normal programming languages, we know, right? We will check the syntax errors. So whether it is correct or not. But here, verifying formally is nothing but you need to check the functionality also, whether it is functioning properly or not. For example, I'm transferring the funds from A account to B account. So without checking the funds, whether A is having the sufficient funds or not, I'm trying to transfer. Then again, it leads to a bug. Integer overflow. So integer is accepting within range, but if it is reaching to out of range, again it is a bug. So something like that which cannot be checked by the syntax errors or some like compiler, that should be verified formally before deploying this smart contract onto the blockchain. And energy and resource consumption, of course we know like if we use some consensus algorithms like POW, proof of work, it will need more energy and more resources to perform that mining process, so which leads to more computational cost. And next, simplified mining. So security risks. Okay. So some newer blockchain networks use less energy intensive consensus mechanisms such as proof of stake. The solution for the previous problem, that is proof of work. So we can use some other consensus mechanisms like proof of stake, which doesn't need more power or more energy. So while POS is a less resource intensive when compared with the POW. Proof of stake is nothing but I should stake something initially if I want to participate in the mining process. It can be more vulnerable to attacks or centralization if not implemented carefully. This is the problem. If we don't operate it carefully, then it may lead to some attacks. So human errors, of course, it is possible in any technology, in any method, whether it is a traditional one or this blockchain technology, human errors, of course it will be there. So vulnerability in the coding. So whatever, just now we discussed, right? If we don't formally verify the smart contract before deployment, that will lead to the full loss, right? So who is responsible for that? Obviously human is going to write the code, right? So he is responsible for that error. And operational errors. So users and administrators may also make some mistakes when interacting with the blockchain network. So if I don't use it properly also, it will lead to some problem. So mismanagement. Since blockchain networks are decentralized, mistakes in the governance or network management can become widespread quickly as there is no single entity to address and resolve the issue. So if I get any problem, there's no person to contact, right? If I get any problem with the MLR ID website, then I have some person to contact. If I contact them, he will tell, right? But here, if I don't handle it properly, to whom should I ask, right? There's no central person to ask here. So that's about this PPT. So in this presentation, we discussed about the blockchain implementation limitations like scalability, technical knowledge, security concerns and flaws, and also implementation challenges like transaction processing speed, operational cost, storage constraints. Simplified mining is a solution. So formal contract verification, and also human errors. Thank you.